Thank you for being here. My name is Alejandro Bonilla. I'm a domain solution architect. If you've had a SUSE Virtualization presentation done already by someone, I may have already been there because I've done a few hundred of these the last few months.
And my name is Alessandro Pilotti. I'm the CEO at Cloud-Based Solutions. So the company is making the tool that you will see today for migrating VMs from VMware to SUSE Virtualization.
Perfect. Thank you, Alessandro. And we share a lot of things, but the best one is our name, of course. It's just one is in Italian, the other one. So that's our agenda. All right, let's lower that down a little bit, please. And we'll talk a little bit about SUSE Virtualization, just a little bit, because we're going to focus on the topic of virtual machine migration. I literally have 4 or 5 slides, and then we'd let Alessandro do its thing. We'll do a demo at the end, too. And do you want to talk about the agenda as well?
Yeah. After the introduction, we will go through the whole context about why we're going to migrate. It's, of course, a hot topic, given the number of people which are here, right? And then we're going to show what Coriolis is, which is actually the project that we're going to talk about for migrating workloads, right? And some of the details, how it works, what its objects are, and so on. And then we're going to do a full-fledged live demo migrating actually a VM from VMware to SUSE Virtualization.
All right, thank you. And to quickly go over, for those that aren't super familiar with SUSE Virtualization, it's built on 4 pillars. It's 100% open source software that reduces your reliance on any boutique hardware. And you can just use pretty much, they call it off-the-shelf hardware, or your current investments. It bridges the gap between your legacy or your virtual machines and your cloud-native architecture, your cloud-native workloads. And it's a turnkey solution, which means that the moment you install it, it's ready to go. And networking, storage, and most of the components you need to start deploying virtual machines and container workloads is available to you. Some of the reason why it's creating, it's to drive the value for modern IT. We have a few of those examples here. The first one is operation simplicity, so that you can have both containers and virtual machines on the same platform, giving you all the facility to bridge the gap between containers and virtual machines. We'll migrate those virtual machines into the environment using someone's technology here. And then, as we see and assess the environments, we can then make those migrations into a cloud-native configuration. It's future-proof IT because it's enabling you on what's already here, what's continuously coming, and because the cloud-native landscape, it's huge. The adaptability and how we can expand the platform with the ecosystem clearly tells us that the containers as a platform is where we want to be and where we want to go as well. We avoid vendor lock-in. And I was just talking with some of the people that were here like 20 minutes before the session started. And they're like, oh, we're doing something very similar, and it's just from this other vendor. And my answer was, okay, terrific. So you're moving from a proprietary vendor to one that uses 95% the same technology of what we're building our technology as well. So whenever you need to move from one or the other, there's a minimal technical depth. So it's great for you to then choose from one or the other, pretty much how we did before for Linux, right? And the cost efficiency, right? So it's just the TCO of using open source software and subscriptions. Right, so what can we deploy on SUSE Virtualization? The first one is hosting containers on bare metal, right? So we can deploy containers on the host itself. Why would we do that? Well, we have high performance components, any sort of AI, inference, transactional databases, or anything really that requires bare metal performance, right? You cannot really do that today with your hypervisors of choice. Maybe you can absolutely with SUSE Virtualization. Then hosting VMs directly on bare metal. That's kind of what we're going to talk about today, because you're migrating from a VMware into SUSE Virtualization, and that's just that purpose, right? Running your current Windows, Linux, any other VM into SUSE Virtualization. Then hosting container workloads. But we already talked about that in the bare metal capacity. What about if we want to run different clusters with different versions and they're running different CNIs? They have different life cycles. They need to be isolated, and they might be more ephemeral. That's when the value of rancher provisioning on top of SUSE Virtualization kicks in, where we can then have our clusters as a service and do the things we do today with rancher. And of course, there's a hybrid option where you can use all of these at the same time. What that allows us to do then is assess which are the virtual machines that need to stay as a virtual machine and which are those that can make it as a container. Can we easily port these certain services as a container in our platform, whether we can do that today or after being migrated, but on the same virtualization system. We've got 2 more slides. As an introduction of what the stack looks like, we start from the bottom. First is SUSE Linux Micro, which is our immutable version of SUSE Linux Enterprise. Then, of course, RKE2. It's our Rancher Kubernetes engine. Longhorn, SUSE Storage is our software-defined storage. And then the tooling that pretty much talks with Kubernetes and KVM, which is called KVert. Then there's, of course, other components with regards to the UI and the glue that puts everything together. In reality, that is Kubernetes, but as a bundle, it's called SUSE Virtualization. And my last slide is pretty much how everything looks put together. So we have our system, we have a bare metal system, our kernel, then the different type of drives. We have SSDs and VMEs. We can create different tiers or storage classes so that then we can have our virtual machines on its right hardware architecture. Then we are also enabling possibility of attaching external storage, right? As you can see in the middle of the screen, those are provided through the CSI of your preferred storage vendor. Okay. And then what we do is with the SUSE Virtualization UI, pretty much simplify the process of creating virtual machines, managing those, doing live migrations, and pretty much all those classic VM operations that you expect. All right? Thank you, and now we'll move on to Alessandro.
So, thank you, Alejandro, for the initial context, right? So, about what SUSE Virtualization is. Now we are going to switch to the context about why we are going to migrate, what is actually the purpose of what we are doing here, and how Coriolis, which is the tool that I'm going to introduce, works actually to perform that. Obviously, it's an important topic, otherwise we wouldn't have a full room today. The main idea is that there are always changes in generations in technological, in the technological world.
So we moved from physical servers to virtual machines to infrastructure as a service to containers to some serverless, at some point. And there are a lot of ways, which you can do actually handle those transitions. You can just, rewrite completely your line of business applications, from one generation to the next one. Let's say what very often people in the cloud native world will tell you, just rewrite everything, and just forget about the old. But if you spend 20 years writing your current generation of applications, there's no chance you're going to do it overnight, right? Sure, everything nowadays is typically a hybrid. You have the old stack plus the new one. And this is actually where something like SUSE Virtualization excels, because it allows you to have both VMs and containers within the same management boundaries, right? So you want to improve your TCO, you just don't want to get rid of everything you had till now and having to rewrite everything as we discussed. There are also cloud-driven returns from public clouds to on-prem and vice versa. There are new edge scenarios. There are a lot of scenarios why you might want to migrate. New on-prem hardware, for example, on-prem to public cloud to on-prem redeployments. There are so many different scenarios. For example, in the case of VMware, you're simply transitioning from one platform to a new one. There are many options: rehosting, replatforming, repurchasing, re-architecting, and so on, right? I'm not going to go into details in all of those because it will take quite some time, right? But I'm going to refocus on the so-called rehosting. Rehosting is also called lift and shift, okay? Lift and shift means that you take, in our case, virtual machines or physical servers from one source and you move them to the target. The idea is that they look like black boxes. So from the user's perspective, they will find the same identical content transparently moved from A to B, okay? So this is very different, for example, from replatforming, which consists in taking your applications, containerize them, for example, in the current Kubernetes and Docker world, right? And move them to Kubernetes, for example, right? With lift and shift, we do something conceptually more basic. You have a VM on your source, let's say VMware, and you're going to have the same identical VM on the target, let's say SUSE Virtualization. There are some disadvantages also with this approach, which is the fact that you are not really taking advantage fully of the new cloud-native paradigm, right? For that, of course, you need to rethink your applications, but very often this is not needed, especially for applications which were not born for that, right? Okay, this sounds very easy and simple, right? But in reality, there are a lot of steps involved and a lot of differences. For example, on the surface, VMware and the virtualization technology, which is used by SUSE Virtualization, right? KVM, QEMU, and so on, are just virtualization solutions, right? But in reality, there are a lot of differences under the hood. Different virtual disk formats, different type of synthetic kernel drivers, so the drivers within the guest operating system that allow you to perform I/O, networking, and so on. Init.rd needs to be rebuilt typically on Linux VM. Is a Linux configuration, SA Linux will, of course, not allow you to run the same VM if it detects that the underlying hardware, virtual or physical, changed. Different PCI IDs, different network configurations, different provisioning agents. For example, VMware tools or similar, for example, on the VMware side, cloud init, cloud-based init, and so on the target side, and so on. Coriolis was born. So Coriolis is the project I'm going to introduce right now for doing the migrations. It's something that was born a few years ago, actually, around 10 years ago, when we needed, in cloud-based, to migrate from VMware to the OpenStack deployments we were doing at the time, right? So this is not a new need. Of course, it got significantly accelerated by the changes in licensing policies, of course, that Broadcom made. But it is something that it's needed since a long time. So we have a very mature product in the end that started already almost 10 years ago. The purpose is to take all those complicated steps and automate them in a cloud-native type of solution, okay? So the idea that you want to do fully automated lift and shift migrations from and to any cloud or virtualization solution, okay? So ideally, as Alejandro was also saying, you want to avoid vendor lock-in. You want to move from point A to point B freely whenever you want and need. You want it to be scalable. You want to be able to perform one migration or 1,000 migrations at a time, right? Many of our customers are transitioning completely from an architecture to another, which involves thousands and thousands of their VMs, right? You could do it manually, theoretically, right? But it's extremely time-consuming, extremely error-prone, right? And problematic. With a tool like Coriolis, you can just automate the whole process and not having to think about it. We have a REST API for full automation, as we'll also discuss later. You have a Keystone for identity management, so you can actually have multiple different type of users involved there. A quick overview here. Coriolis is agentless. This is very important. So when you have thousands of VMs to migrate, you don't want to have to install something inside of those VMs. You have so many different operating systems, so many different users and tenants and everything. It will be very difficult to go and tell to each of them, hey, go and install this particular piece of software. In our experience, it's just not going to work. It's just like an extremely big overhead from a management standpoint. So we designed Coriolis to be agentless, meaning that we don't need to install anything on the source VMs. We have a scalable architecture, so at any time you can decide to increase the number of machines you're going to deploy in parallel, as long as, of course, as you take into account your physical limitations, meaning how much bandwidth you have for that, how many IOPS you can consider, of course, for storage and so on. We consider also data replication with zero downtime, so we don't want to require our users to having to shut down the source virtual machines while the migration is in progress, right? So we want to ensure that business continuity lasts as long as possible. Ideally, you have your machines running on VMware. At some point, you shut it down, and you move on to the machine which is on SUSE Virtualization, and it just works. REST API and a friendly UI. So we take into account both DevOps requirements. You know, in the DevOps world, you want to automate everything, right? You want to use whatever source of automation you might have. And we want this to be integrated as easy as possible also with Coriolis as well. That implies also that on top of the REST API, we have also a CLI, so a command line interface, and we have also a graphical user interface, which is what I'm going to show you in the demo very soon. We have an integrated scheduler, so you don't have to just do all the migrations at once. You can also schedule when these operations are going to happen. And last but not least, it's designed to be secure. Our customers typically have a very, very stringent security requirements, and we want to make sure that Coriolis meets those set of requirements. Right? In terms of architecture, Coriolis is made by a bunch of different microservices. I'm not going too much into the details right now, but let's say you have a UI, you have an API endpoint. We use Keystone, as I mentioned before, for authentication, which means that you can use a very large number of different plugins, you know, to integrate, for example, with Active Directory, with whatever OAuth provider you might have, and so on. We have a conductor, which is what actually decides what needs to be done at what time. Barbican, which is another open source project, which handles secrets, okay, in a safe way. Of course, a database for configurations and everything, a scheduler, and also the so-called Coriolis worker components, which are the components which are actually talking to your source and target cloud or virtualization solution. In our example today, it will be VMware on the source and SUSE Virtualization on the target with KubeVirt. We support a very large number of clouds and virtualization solutions. So we have AWS, physical Linux servers on bare metal, Azure, Hyper-V, OpenStack, Oracle VM, VMware, and many more. And on the target, we have, for example, AWS, Harvester, KubeVirt, Azure, LXD, OpenStack, OCI, OLVM, and a variety of different Oracle platforms, so PCA, OVM, and so on. We support Proxmox, and so on, right? We added also support for bare metal migration, so if you have servers which are actually physical servers and not running as VMs, we can allow that as well. In that case, of course, we need an agent because we need the way Coriolis works is that it talks to the underlying infrastructure, right? In the case of VMware, of course, the API that VMware provides. But in the case of bare metal, there is nothing underneath, of course, beside the APMI and similar. So you need an agent to do that. But Coriolis allows you to do that in a very automated way. The way Coriolis allows you to magically basically convert those machines from the source format into the target one is a process that we call OS morphing. It's basically consisting in replicating all the data byte per byte from VMware in this case, right? Moving it to the target, in this case a volume, right? A PV, persistent volume in the context of SUSE virtualization. Attach that to a temporary virtual machine that we are spinning up automatically. Inspect the content, and based on the operating system we find out, perform a given set of steps, okay? If it's a SUSE VM, it will need to have some particular steps in removing some packages, adding new ones, rebuilding, if needed, kernel init RDs and so on. If it's a Windows one, it will need, of course, to reconfigure kernel drivers, change network configurations as needed, and so on. I'm not getting into the details, but there are a lot of specific steps which are specific then to the guest operating system, Ubuntu, Red Hat, and so on. On top of that, you can also inject whatever script you might like. Would you like to install some extra packages? You can do that at a stage. It's automatic. Would you like to add some software which was not included when it was running on VMware? You can do that as well. Huh? So we allow a high degree of customization at this particular stage. Supported guest operating system, so basically what is running inside of your virtual machines. Ubuntu Server, Oracle Linux 7, Red Hat Enterprise, CentOS, Rocky Linux, SUSE, SLE, right? OpenSUSE, Debian, Amazon Linux, and on the Windows side, pretty much every Windows supported version, right? So in this list we have Windows RE 2016, 19, 22, 25, and of course also clients, which will be Windows 10 and Windows 11. Coriolis has a very nice GUI that we are going to see very soon. What about downtime, right? So when we talk about migrations, there are a lot of migrations tools out there in the wild, right? But typically they involve you and they require you to shut down the source machines, do a lot of manual steps to copying the data, starting on the target. In our case, we take into account the idea that the downtime has to be limited to zero, close to zero, right? We want those machines, as I mentioned before, to run always on the source target till the moment in which the user decides to shut it down and start the target, right? And in theory, you can even run them in parallel. To the point that we also have disaster recovery as a service features included in Coriolis. So Coriolis doesn't do only migrations as a service, it does also disaster recovery as a service. It's what we call internally replicas. Migration is performed as the last step directly on the target cloud. There is no need for the source VM to be available. Very useful in case of disaster. Otherwise, disaster recovery wouldn't be particularly useful. When we talk about DR, we typically have two important metrics that we have in mind. RPO, so a recovery point objective, which is the last replica execution, and the recovery time objective, RTO, which is the migration from the last replica, which is basically the time the operating system takes to be converted and boot, right? So something in the matter which runs from 30 seconds to 5 minutes, depending usually on the target environment. Public clouds are typically a bit slower, and private cloud environments tend to be faster on this. In Coriolis, you need to tell, of course, the platform how to talk to your source and target clouds or virtualization solutions. This is what we call cloud endpoints. It's basically where we are going to put your credentials to connect, in our case, to VMware and SUSE Virtualization. How do you deploy Coriolis? Coriolis, as I mentioned before, is made by a bunch of microservices. Those microservices can be distributed in various ways. The one that we found out our customers tend to prefer is a very simple single appliance, meaning a virtual machine, that gets deployed on your target or source environment, so on VMware or SUSE Virtualization, and it just contains all the bits and pieces which are needed for Coriolis. So no need to install anything else, you just start this VM and it just works, right? Or you might also deploy the various microservices independently. For example, you might run them individually as containers in a Kubernetes environment, right? As a deployment. It can be scaled up both horizontally and vertically based on your requirements, because again, it's designed as a cloud-native type of application. Licensing, last but not least, I will say, is based on the individual virtual machines. So if you migrate 10 virtual machines, you use 10 licenses, okay? Which are counted only in the moment in which the migration happens successfully, okay? Similarly, we have also disaster recovery licenses. The big difference between disaster recovery and virtualization is that disaster recovery is a continuous type of operation, meaning that you don't do it as a one-off thing, right? It's something that keeps on going all the time till the moment in which you decide, say, to stop because, for example, you change your environments and so on. In that case, the disaster recovery licenses are monthly type of licenses instead of being a one-off thing. But conceptually, if you want, are very similar. Last but another topic, multi-tenancy. Multi-tenancy, it's very useful in any type of cloud environments. Even in something that might seem some relatively straightforward, like migrations, you might need to have a lot of different users involved. You might have people which are colleagues who might be involved in performing the technical steps of the migrations, colleagues which might just want to audit, the migration steps and everything, or the number of operations being performed and so on. You might want to have multiple tenants within your organizations which are performing migrations at the same time, so you don't want them to see each other's VMs, right? And so on. All right, time for a demo.
All right, what you're seeing here is the Coriolis dashboard, okay? So it's talking behind the scenes to the API endpoints that Coriolis provides. Then we're going to have a VMware environment, which is where the VMs we're going to migrate from live right now. And we have Harvester, okay? SUSE Virtualization, which is our target, of course. Okay, let's start by showing endpoints. So in Coriolis, you have this nice menu on the left, and on the right, you have a series of endpoints. As I mentioned before, those are the connection points that tell Coriolis, hey, this is how you're going to talk to VMware, and this is how you're going to talk to SUSE Virtualization. Meaning, basically, just the endpoint in IP address of the FQDN of connection point, right, of your server, and the credentials. You can also create a new one very simply from here. You select which type you want to select. Let's say you select VMware, and it's going to ask you all the basic information like, okay, you give it a name, a description, a username, a password, the host, which port to use, and so on. And similarly, we'll create a similar one also for Harvester. We don't need to do that because they're already pre-created. We have a third one here, okay, we're not using it for the demo, which is for bare metal connections in case you want to migrate from bare metal. Transfers. Transfers is where you create actually what internally we call a transfer, which could be either a disaster recovery replica or a simple migration. So right now we're going to do a migration. So create one. Here you select which of the two. I just flick the switch on the left to migration. Next. Then I select my source. So the ones in gray are in gray because there is no endpoint configured, right? VMware is not grayed out, and there is only this one. If I had multiple VMware environments, they will show up there, and I could just pick the one I like. Then I select next. Some basic information about specific, let's say, details related to VMware which are not entering the details. One thing Coriolis can do for you, if change block tracking, which is the technology used for doing this seamless type of snapshots on VMware is not enabled, Coriolis can even enable it for you.
You just have a switch there, right? Then, now Coriolis is connecting now to VMware and getting a list of all the possible VMs, okay? Which you can actually filter. We're going to use this OpenSUSE Leap 15 here, okay? 15.1. I have also Windows 1 and so on. You can search the VMs, filter them. If you have a very long list, it's very handy. And most important, you don't have to do a single migration at once. You can do many migrations at the same time. Very useful when your application is spread across multiple VMs, because you're migrating in the end a whole workload. You're not just migrating a single VM, right? On the target, I'm going to select KubeVirt, which is the virtualization technology which SUSE Virtualization is using. Here I have some details. I'm not going into the details. They're all pre-populated because we have configuration files which are already set up for your environment, right? So you don't need to tell all the tiny little details, but you can override all of those if needed. In our case, we keep it simple. Next, we have to map the network. So Coriolis identified to which networks your VM is connected to on VMware and says, okay, I found out that this VM has 1, 2, 3, whatever network connections. You need to select which networks you have on the target. We have a simple case, in this case, in which we have a single one. And these are actually networks which are available in Harvester, okay? So in this case, Coriolis is connected to SUSE Virtualization, fetch the list of networks, and then you can select the one you want. Similarly for storage, we are moving from VMDKs on one side, and we are going on Longhorn storage on the other side. So I don't have to change anything. I leave everything as default, because Longhorn in this case is my default storage. Meaning that we are going to create some persistent volumes and persistent volume claims that are going to be attached then to our virtual machine. Here, we could add some custom scripts that you might use for personalizing, as I mentioned before, your migration, your VMs, right? You might want to inject packages, want to configuration, this is the time to. You can do it either for all of them or individually for each virtual machine. You can schedule it. You can select when you want this to happen. In our case, it's of course right now, since we cannot do it after the session finishes. We want to execute it right now. Coriolis allows you also to shut down the instance before doing the last transfer. So if you want to shut it down completely and start it on the target, Coriolis can do that for you, right? Or you can leave actually the machine running on the source, and you can have it on the target. Last but not least, we also select auto-deploy here. Auto-deploy means like once you put all the data on the target, also perform the full automatic final migration. Okay, before doing this, to show you that I'm not cheating here, I'm going to show you, I'm going to connect to VMware. I'm going to connect to the console that we have there. And I'm going to just create a file, which shows you that we have some content that changed on March 11th at 11:36 a.m., right? So now we have a file, which is that. Now we go back to Coriolis. We do next. Some details about all the steps. So if you're not happy, you can. We are happy, and we click Finish. So you can see here on the screen a bunch of individual steps, okay, which are being executed as we are talking. The first step tells you, okay, I want to validate the data that you pass me, because you don't want to spend 1 hour doing a migration and at the end realize that you forgot to set something that is required, right? So Coriolis validates everything at the beginning so that there are no surprises later. Get to VMware and fetching all the information. For example, how much RAM does this machine have, how many vCPUs, how many disks, and all this data. Similarly, Coriolis also performs some validation on the target, making sure that SUSE Virtualization is capable to perform, is configured to perform what you're actually asking it to do. Then, Coriolis creates for every single disk on the source VM, a disk on the target. In this case, a disk is a persistent volume, okay? And it's empty. So those are empty volumes of the same identical size as the source disk. What's happening now is that on the target, Coriolis is spinning up a temporary virtual machine with a particular image which we already predefined. So a very simple Linux machine. There is nothing particularly magic here. And it, as you get, it creates the VM, attaches the PVCs, so basically it creates a persistent volume claim of that volume that we created, it attaches it to this particular VM. So if I go here, I can see that now there is a temporary VM with, of course, a name, which is spinning up, okay? This takes a bit longer, right? We have also a feature called minion pools, where we can also pre-create a bunch of these temporary workers and leave them running and everything, right? Which is a feature which are currently adding also for SUSE Virtualization. That means that you don't have to wait for this process to happen. The machine is already ready there in a pool, right? You just fetch it from the pool, assign it to the work, finish the work, return them to the pool, right? To be used carefully when you use, like, of course, public clouds, because those are machines which are going to be built right at the end of the month. But of course, on a private cloud environment on premise, it's a different story. You can just have a bunch of them always available, and they get assigned to the various virtual machines. We need two types, one for Windows and one for Linux, right? Of course, if you're migrating both operating systems. It's done. And now we start with so this machine, Coriolis connected a channel, a secure encrypted channel with this temporary VM, and is starting to read data from a snapshot that he created on the source. And mind that in VMware, snapshots are crash consistent and app consistent, meaning that even if you have databases and everything, Coriolis this way makes sure that the machine you're going to have on the target is in a state which is able to fully function, right? If you're not sure that your source machine that, you can always tell Coriolis before doing it. It allows us full business continuity because, as you can see, the machine is alive and running, right, while this operation happens. So now you see a progress bar, and you see the data being transferred. You see over down here. We have a single VMDK. We had multiple VMDKs. All those VMDKs will be migrated in parallel, okay? Easy. So now, of course, I'm looking what's happening here, but I could have perfectly gone and take a coffee and come back, right? But probably that wouldn't be very good for, for a presentation. In the real world, you just start a bunch of migrations at once. You just forget about them, come back, and look at the results, right? Okay. Should be relatively quick. Of course, this, and it tells you also, Coriolis, of course, is also smart in the sense that it detects that this disk has 21 gigabytes, okay, out of which only 3.4 are actually in use, meaning that it doesn't need to copy all the zeros, okay? It detects the ones that need to be copied in terms of blocks, right, not files. Coriolis doesn't care what type of system you have, right? Okay, almost there, 94%, 99%. And it's done. Okay, so the disk replication finished. Now we are deleting all the temporary resources. So Coriolis is always extremely careful not to leave behind anything because, especially in a public cloud, if you have some errors and everything, you don't want to have some orphan and temporary VMs that you forgot there. So Coriolis is extremely careful about deleting things. Also, we do extra logic to make sure that all processes are resilient because, of course, in clouds, you always have to deal with transient failures, right? There might be a situation that you might get an error from an API endpoint. You cannot just, failed a 1 hour operation just because of that. You want to retry and apply some logic to make sure that everything works. Good. So this process finished, meaning that now we have a full-fledged replica on the target. A replica is a copy of the disk, byte per byte, of the source, okay? Now, we cannot just run that target. We need first to convert it to the format used by SUSE Virtualization, which is actually what we call here deployment. It's relatively similar conceptually, meaning that we do a bunch of validations and everything. We create a disk snapshot. There's also an optional feature, which is very useful because our customers very and the migrations ahead, you know. You want to make sure that your workloads are going to work on the target, meaning that this way you can do a temporary test migration. So you already have the volumes on the target, which is the time-consuming part, no? You migrate, you create the VM, you perform all your tests, for example, continuous integration and whatnot, and then you say, okay, I'm happy with it, and then you can just kill whatever you created temporarily, and whenever you want, you just finalize the migration, doing the final type of deployment, right? This works by simply having volumes and creating snapshots on the volume, right? You delete the snapshot, you revert basically to the same identical copy, byte per byte, of the data that you copied from the source. Okay, we deploy another temporary VM. Same identical process that we saw that you guys saw in the steps.
So question in regards to zero downtime.
Yeah.
So in the example that we saw here, we saw this running basically a machine that looked like, we're not writing a significant amount of data to it, and it's able to take the snapshot. And we can see that that snapshot takes some time for it to transfer over. What if we're doing something like a database, something that is getting continuous read writes?
That's a wonderful question and something I wanted to get as well. Coriolis does incremental replicas, okay? It does, now we did the simplest one, of course, to go quickly through the demo, right? But in the real world, you will do a first full-fledged replica, and then you will do incremental ones, okay? So typically, this one takes a lot of time, and then you perform incremental ones, which just copy the delta from the last execution. Perfect use case, databases. You might have an OLTP database with a lot of writes, Then in that case, you copy basically only the blocks which changed since the last one, right? And you can perform it as often as you want, right? This is particularly useful for the disaster recovery as a service use cases because you don't want to have this whole process all the time. You do it once, and then you simply keep up to date the data with the data like latest bits and pieces.
But you're always going to be slightly behind. So say if I was doing a replication of a database, I would do like maybe have a read replica set ahead and do a promotion instead. Is there a chance where you would never actually be behind?
Well, so to be clear, this doesn't replace, of course, replication solutions that you have at the database level. Let's say Oracle SQL Server, mirroring, for example, stuff like that, right? Those are at application level. In this case, Coriolis, of course, reacts to changes which are within the data, right? So the application has to have written the data and the system, and then having executed a replica that recognize that the changes happen and have to be proposed. So the only scenario in that case, if you have zero data to replicate, typically is when you shut down the source and perform the last step, right?
The problem with cost would probably turn off one of those replicas, make it faster, and then switch it over quickly, and then it just synchronize again.
Right, but there's still that there is a potential for downtime specifically.
Not if it's a replicated database. There's other components that are already serving that replica. There's a degradation of the replication of the database, but it's still up because one of them is down because you're migrating.
So it's better to fail over to another database while you're moving it.
Yeah. So this is a migration and replication tool, right? It's not a database tool, right? So this is very specific. Okay, very important. So now that's one of my favorite steps. This is called OS morphing, which is the last important step. As you can see, it connected to the temporary VM. It detected that the machine came from VMware, so it removed the open VM tools. And it detects, I'm going to SUSE Virtualization, so I'm installing Cloud Init and the QEMU guest agent. Okay. If this was Windows, we would have installed Cloud-based Init. Right. Okay, this is a very quick step.
What performance impact does this have against the source system, and is that tunable in terms of IOPS, network speed, those kind of things?
Yeah, that's another good question that I briefly touched on before. The very important thing that needs to be done, let's say from an administration standpoint, is to decide how many migrations you want to do in parallel because of the impact on the IOPS and on the networking. You don't want to kill your whole network and your whole storage while this happens. You want this to happen in a way in which it's completely seamless for your users, which can be done either by, if you have the luck to have something which is not working 24/7 during offline hours, right? Or if it's during online hours, you can decide, okay, I'm allocating this amount of IOPS and networking, let's say, for the migration, right? Meaning that you can tell Coriolis how many operations in parallel should be executed. So Coriolis, even if you tell Coriolis I need to do 1,000 VMs, it will not start 1,000 VMs to be migrated at the same time. It will start the maximum parallel number that you set, okay? In the case of Coriolis configuration, this is set per operation, because Coriolis, of course, does not have direct visibility to the underlying technology. But, of course, you can bridge it together with QoS and whatnot that you might apply. Basically, because in the end, Coriolis connects to source and target with credentials, right? So you can assign quotas to those users, QoS and whatnot, and you can bridge those two gaps, basically. Right?
We can do one last one. If it's, go ahead.
Okay.
Yeah, so does this support Kubernetes migrations, or is it just VM migrations?
This is, quote-unquote, just VM migrations.
Okay. And one other point. Could you use this to remain on the same networks if you configured both endpoints with the same networks?
You can. You have to be, of course, careful because Coriolis allows you to do a couple of things. You can retain, for example, even the MAC address, meaning that you have Coriolis fetches the MAC addresses from the source, and if you want, reassigns the same MAC addresses on the target, right? In that case, it's very useful because at that point, the DHCPs and whatnot will recognize the same VM, basically, right? You want to make sure that you don't have both of them running at the same time. So remember that features that allows you to shut down the VM before this happens? That's what you want to use in that case.
Yeah, that part can get messy pretty quickly, I
think.
With the DNS and
sorry,
IPs.
the migration finished. So last step here. So everything is green, as you can see, which also means that now here in SUSE Virtualization, I can find my VM running. So I start a serial console. I log in. And here is our timestamp file at 11:36. Okay. Thank you.
Thank you very much for coming. If there's any questions, Alessandro and I are around. We're here all week.